Alright, so the basic type of quadratic equations are ones that only have an x squared in them. And so if you're going to solve this, most people can just think, okay, well, what squared is 9? Well, 3 squared is 9, and negative 3 squared is also 9. And so this is just a refresher on that whenever you take the square root, you're going to need to remember plus or minus. And so that is the biggest thing out of this whole thing that you can remember, is to remember plus or minus every time you take square root of both sides. Now, sometimes people get this confused because if you were just to take the square root of 9, the square root of 9 is still just 3. This is what we call the principal square root. But when you take the square root of both sides, when you have an equation and you're looking for what x makes that true, that's when you have two answers. Equation, two answers, an expression, just one. So, if you're solving this, get the x squared part by itself. So divide by the 5, divide by the 5, and so x squared equals 36. I'm sorry. I type it into the calculator because when I do this in front of all you guys, I make mistakes and I look stupid. So, plus or minus 6 when you take the square root of both sides. Add the 4. 8x squared. If you add 4, you get 40. And then divide by the 8, and you get 5. And when you take the square root of both sides, we can't take the square root of 5, and so I'm just going to leave it as square root of 5. You can also get the approximate answer to that. Square root of 5 is 2.24. And so either one, this is what we call the exact, and this is what we call the approximate. And so we'll have times where we ask for both, because I'm going to show you how to find approximate answers graphically as well. So for this one, x squared on either side, so I'm going to add x squared. And so if you add x squared to both sides, it cancels it out on that side, and you get 2x squared plus 1. If you subtract 1, you get 1 and 2x squared. So now divide by the 2, you get 1/2. So 1/2 equals x squared. Now you take the square root of both sides, remembering plus or minus. And I'm going to flip this around. X equals plus or minus the square root of 1 over the square root of 2, and there's a plus or minus here. Now that's the same as plus or minus 1, because the square root of 1 is 1, over the square root of 2. Now, traditionally, we don't like the square roots in the bottom, and so what we have to do is rationalize it. We're going to talk more about this on the opposite side of this, but we're going to multiply this by root 2 over root 2. 1 times root 2 is root 2, and root 2 times root 2 is root 4, and which is 2. So you get plus or minus root 2 over 2, and that is the answer. The reason this is a bit old-fashioned is because before calculators, they would want to approximate the root first and then divide by 2, because it's a lot easier than dividing by the approximate root. So it was very practical, but now that we have our calculators, it's not quite as practical. So, things to realize. When an object falls, and we're not going to use throwing, we will later on, but when an object falls, it speeds up. It's called gravity. And we can use the quadratic equation to model its height, because gravity makes it speed up every second upon second upon second, and so that's why it's negative 16t squared. Gravity is 32 feet per second squared. And h sub 0 or h null represents the starting height, and t is in seconds. And so, calculate the height of a baseball after 3 seconds if you drop it from a 200-foot bridge. So if we put in what is h, negative 16t squared plus 200 feet. So we would, what is h after 3 seconds? Add 200. So negative 16 times 9 plus 200. And we get 56. So the height of the baseball is 56 feet. And so we could say, well, how high is it, or how long until it hits the ground? Hits the water. If it's a 200-foot bridge, h equals 0 is what we're looking for. So if 0 equals negative 16t squared plus 200, we can add 16t squared or subtract 200, either way. T squared is 200 divided by 16, 12.5. And if we take the square root of both sides, remembering plus or minus, except we're going to ignore the square root in this one. Sorry, we're going to ignore the negative. So we're going to ignore the negative and just say 3.54 seconds. Because it's not going to hit it negative 3 seconds ago. That doesn't make any sense. Alright, another thing that can involve quadratics that you've actually done before a lot is a little right triangle, a little Pythagorean theorem. A squared plus b squared equals c squared. And so, remember, the biggest thing in this is that 41 has to be c. That has to be the hypotenuse. And then 9 squared plus x squared. So x squared equals 41 squared minus 9 squared. Now, one common thing I see here is that people take the square root now and just think it's the same thing as 41 minus 9. Note, square root of, 41 squared minus 9 squared, and then taking the square root, is not the same thing as 41 minus 9. So, x squared equals 1600, and x equals 40. And again, it's plus or minus, but because it's just a length, it's 40 all by itself, which makes sense. This squared plus this squared equals 41 squared. Alright, another. From 2000 to 2008, the profit P in dollars of a company could be modeled by this profit equation, where T equals 0 represents 2,000. So if you plugged in 0, we made 52,500. According to this model, when would the company have a profit of 2.64 million? So I want to know, when is the profit P equal to this? So I'm going to plug that in for the profit. 9,400 T squared so 26, 40, 1, 2, 3. Subtract out our 52.5. And we get divide by the 9,400. And then take the square root. So we get T equals 16.59, or let's just say 16.6 years. After when we started this. And so what we're talking about is 2000, t equals 0. And so really it's in the year 2016 that we're talking about that we'll have that profit. So, on to what happens sometimes, like what we saw with number 3, that we have to be able to deal with square roots and rationalize them and simplify them. And so we're going to get back to the basics of something you've probably seen before, hopefully, like reducing square roots. You might have made factor trees before. So 72 has like a 2 in it and a 36. And so because this is the square root of 36 times 2, and maybe you saw 9 in there as well, and we'll talk about that. So 36 times 2, the square root of 36 times the square root of 2, and then 6 square root 2, because the square root of 36 comes out. Now, had you seen 9 times 8, and then you would make it 3 root 8, but then 8 has some more in it. And so you have 3 times the square root of 4 times the square root of 2. Then you pull the 4 out, and you get 3 times 2, which is the 6, and the 2 left over. And so you get to 6 root 2 anyways. And so it brings up the question, how do you know when you're fully done? So the first step to that is know perfect square factors left under the radical. Now, that is a lot of big time words going on here. We've said perfect square, meaning 9, 16, 25, 4. Those are perfect squares. 2 squared, 3 squared, 4 squared, 5 squared. And factors, meaning multiply. They multiply to the number you're getting. Alright, so now the second part of it is the quotient property. Is we can separate a fraction into the square root of the top, square root of the bottom. And so the square root of 49 over the square root of 36. And the square root of 49 is 7, and the square root of 36 is 6. So this comes in handy. Sometimes you can take the square root of one number, but not the other. So, you guys try these. Try to reduce it. Really, pause it and try it. Square root of 28. I notice that there is a multiple of 4 in there. And so I'm going to think 4 times 7 equals 2 root 7. Try another, 150. So I see within 150, first thing I see is 25. And 25 fits in there 6 times. Because you got 50 3 times, so 25 6 times. And we can take the square root of 25 and the square root of 6. And so the square root of 25, so 5 root 6. Again, if you have your calculator handy, it's nice to be able to say, well, square root of 150 and 5 square root 6, they're the same thing, just to know that you reduced it properly. And in the same way, you can go backwards through this property and say the square root of 6 times the square root of 6 is the same as the square root of 6 times 6 underneath. So that's 4 times square root of 36, which is 4 times 6, which is 24. And so the second part to how do you know when you're fully done is no radicals in the denominator. In the bottom. This is called rationalizing the denominator. Get the radical out of the bottom. So, same reason that I explained before. It's a lot easier to take the square root first and then divide. So before we rationalize, actually, let's reduce this a little bit. 7 times, and then this is 4 times 3. So I'm going to change this to 2 root 3. Now, in order to rationalize, we multiply by a form of 1. I'm going to multiply by root 3 over root 3, because what that's going to do for me is on top I get 7 root 3. Square root shows up on top now. But on the bottom I get 2 times the square root of 3 times 3, or the square root of 9, which is 7 root 3 over 2 times 3, or 7 root 3 times 6 over 6. And that's how that one works. Again, when you multiply by root 3 over root 3, it cancels out the root 3. You can multiply by 2 root 3 over 2 root 3. You'll just have more simplifying to do in the end. In order to get rid of one that is a binomial, meaning 2 terms here, we have to multiply by the conjugate. I'm going to multiply by 1 plus root 3 over 1 plus root 3. Conjugates is what this is called. One has a minus in between, one has a plus in between. Notice that they're not both negative and negative, and then positive and positive. It's just a sign in between. And what this does is it intentionally, well, so 2 times 1 and 2 times root 3 up top. And on the bottom you get 1 times 1, 1 times root 3, minus 1 times root 3. And this will always cancel out because we're setting it up to do that. This is the difference of squares. A plus b, a minus b. And then minus root 9, which is really just going to give you 3 every single time. So, what I'm going to do is I'm going to split up, because this has 2 over negative 2 plus 2 over negative 2, like that. And so this can be reduced to negative 1 minus 1 root 3, or just root 3. And so again, like I said, you can double check that you have what you meant when you do 2 divided by 1 minus root 3. That's equal to that, and then negative 1 minus square root of 3, what we ended up with, and they are equivalent. And how do I know I'm done? Well, there's no radical in the denominator, and perfect squares are all out. You guys can try the next 2. So I'm going to simplify the top first, and I'm going to first square root of 18 over the square root of 11. I can separate that. Square root of 9 times 2. Root 2 over root 11. I'm going to multiply by root 11 over root 11 to get the denominator free of that. So I get 3 times, and then this becomes 2 times 11 down there, in there, and you get just root 121 or root 11. So 3 root 22 over 11. Again, I would probably skip from this to this, but I wanted to show you why we're allowed to do that. So 3 root 22 over 11. Number 11, not quite as pretty. But again, we want to get rid of the square root in the bottom, and so we're going to deal with the bottom on this one just like we dealt with this one. So you multiply by the conjugate, which is 2 plus root 10. Remember that we have binomials here. So 3 times 2 is 6. plus 3 root 10 plus 2 root 7 plus root 7d. And then on the bottom you get 4, and then the inside-outside terms cancel, you get minus root 100. Root 70 you want to look for, okay, well that's 35 times 2, but 35 is made up of 7 and 5, and so there aren't any perfect squares in there. So this is as reduced as the top can get, 6 plus 3 root 10 plus 2 root 7 plus root 70, all over our 4 minus 10, which is negative 6. And that is how you reduce radicals and rationalize radicals.